Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review what was covered in week 3. So previously we looked at triangles. A triangle is any three-sided shape. This week we looked at quadrilaterals. A quadrilateral is any four-sided shape. We need to be able to classify quadrilaterals and also find unknown angles. So let's start with classifying. So we're going to name different types of quadrilaterals according to how many parallel sides they have. And then later we're going to further classify them by the number of equal sides or angles they have. So if you have a quadrilateral with no parallel sides, it's either a kite that looks like this or an irregular quadrilateral. Now, irregular quadrilaterals can take many forms. They can look like this, they can look like this. They're just weird looking four-sided shapes. So a kite is also a diamond that looks like this. It turns out kites always have two pairs of equal sides, but the pairs of equal sides are adjacent. They're next to each other. Kites also have one pair of equal angles. It's always the angles where the unequal sides meet. So in addition to looking like a diamond, a kite is basically an isosceles triangle on top of another isosceles triangle. Irregular quadrilaterals, however, are hard to define. So we're just going to define them as any four-sided shape that has no parallel sides and no equal sides that look like this. As I said, they can take many forms. So if you have a quadrilateral that has one pair of parallel sides, it's going to look like this, or it might look like this. We call these shapes trapeziums. So remember, the arrows indicate that the lines are parallel. So these two shapes are both trapeziums. So trapeziums sometimes have a pair of equal sides, the slanted sides. Sometimes they have no equal sides, but they always have just one pair of parallel sides. So let's look at shapes with two pairs of parallel sides. Well, we call those parallelograms that look like this. So this line here and this line here are parallel, and so too these sides are parallel. So it turns out for parallelograms, the sides that are parallel are always equal to each other. So those two sides are equal and these two sides are equal. Now, there are three special types of parallelograms we need to know. If a parallelogram has all of its sides equal, it is a rhombus. If it has all of its angles equal, it's a rectangle. Now, if a parallelogram has all sides and all angles equal, then it is a square. So a square is a type of parallelogram, and so too rectangles and rhombuses are types of parallelograms. So all rhombuses are parallelograms, but not all parallelograms are rhombuses. Similarly, all squares are rectangles, but not all rectangles are squares. So people often like to think of a rhombus as like a slanted square and a parallelogram as a slanted rectangle. But make sure you understand these definitions because people often make errors. If a quadrilateral has all of its sides equal, it's not necessarily a square. A quadrilateral that has all four sides equal is definitely a rhombus. It needs to also have all four angles equal to be a square. So note, you can't have a quadrilateral with all sides equal that is not a parallelogram. You can't have a quadrilateral with all angles equal. That's not a parallelogram. So make sure you know these definitions. Now we're going to classify quadrilaterals as convex or concave. So all quadrilaterals fit into one of those categories. Concave is sometimes called non-convex. So to understand the definitions of these two, we need to know what a diagonal is. It's just a line joining non-adjacent vertices. Non-adjacent means they're not next to each other. Vertices means corners. So diagonals join corners that are not next to each other. And I'll show you an example of that in a second. So convex quadrilaterals fit all of these definitions. Note, any of the special types of quadrilaterals, kites, parallelograms, trapeziums, they are always convex. So convex quadrilaterals have two diagonals inside the shape. So for this shape here, which looks like a parallelogram, its two diagonals are these lines here. They are lines that join corners that are not next to each other. So both the diagonals of a convex quadrilateral are inside the shape. See, this convex quadrilateral has no reflex angles, and each of its vertices is pointing away from the center. So the center's here, this vertex is pointing outwards, same with all the others. Concave quadrilaterals look like this. They're caved in, hence the name. So if a quadrilateral is concave, it's always an irregular quadrilateral. So it has one diagonal outside the shape. So this line here is a diagonal. Even though it's not slanted, remember diagonal is just a line joining non-adjacent vertices. This corner and this corner are not next to each other because there's this corner here. So the line that joins corners not next to each other, you can see is outside the shape. That's what happens in concave quadrilaterals. The other diagonal is here. So they always have one reflex angle. So a reflex angle is greater than 180 degrees. So this angle here is a reflex angle, and one vertex is caved in or pointing to the center. This vertex here, where the reflex angle is pointing to the center of the shape, which is about there. So that's how you differentiate between concave and convex quadrilaterals. Let's now look at finding unknown angles. So for any quadrilateral, whether it's a trapezium, parallelogram, whatever, the angles add to 360 degrees. That's because you can take any quadrilateral and you can divide it into two triangles. So if I draw a line here, I know that this angle, and this angle, the three green angles must add to 180, and the three yellow angles must add to 180, because the angle sum of any triangle is 180, so the angle sum of a quadrilateral is 180 plus 180, 360 degrees. We can use that to find unknown angles. So let's look at this concave quadrilateral here. So because it has four sides, I know that its angles must add to 180. 40 plus 32 plus 38 is 110. So I have that x plus 110 must give 360, and that means that x would be 250 degrees. So of course 250 is a reflex angle, as we'd expect here. Concave quadrilaterals always have a reflex angle. So what about this one here? Well, this shape here I'm giving you as a parallelogram because it has two pairs of parallel sides. So it turns out in parallelograms, opposite angles are always equal. The reason for that is because of co-interior angles. See, this here makes a C. 120 and Z are co-interior. So Z must be 60 degrees because we know that co-interior angles over parallel lines are always adding up to 180. But hang on a minute, these two lines are parallel. We have a C shape here. 120 and X are co-interior, so X must be 60 degrees. Now, both X and Z are co-interior to Y. Look at X and Y here. We have a C shape with parallel lines. So if X is 60, Y must be 120. So they add to 180. So this is what I mean by opposite angles being equal. Whenever you have a parallelogram, the two angles facing each other are always equal. These two are 60, these two are 120. So we can use co-interior angles in trapeziums as well. This is a trapezium because it has one pair of parallel lines. So these two angles here are co-interior, so that means X must be 70 degrees, and these two angles here are co-interior, so Y must be 50 degrees. Once again, co-interior angles must add to 180. So what about this here? Well, to find X, we need to know the shape we have. Because we have two pairs, two pairs of adjacent equal sides, this shape is a kite. So remember I told you before, in a kite, these two angles are always equal. So it's always the angles where the two non-equal sides meet. So 60 plus 40 is 100. I know that these two angles must therefore add up to 260 because all four angles must add to 360. So I'm going to call this angle over here X. So X plus X, 2X, must be 260 because 260 plus 40 plus 60 gives 360. So x is just going to be half that, or 130 degrees. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.